All right. Hello, hello, hello. This is the first of two videos that I'm recording to go over some of the information you guys need for Lab 4, Group 1 metals. Excuse me. There are three videos that you'll be watching over the course of this. The one in the middle is not a video that I have recorded. It's a video from YouTube, but it's going to give you some information that I think you guys are going to find useful for the lab. But first, we are going to talk about the laboratory background stuff. So I guess the first thing I should mention is that if you would like to follow along, I am going to be referencing this piece of paper right here. My printer ran out of ink, but you can find this, or at least a picture of this, in Canvas. So if you want to go into Canvas, pull this up so you can follow along and read along with the information I'm talking about, you can find that there. It is in Canvas under Modules in Unit 4, not quite at the bottom of Unit 4. Right above the exam is the lab section. There is a lab page. It should be called Lab 4 Group 1 Metals. And on that page, there's a bunch of stuff. We are not going to bother with trying to get groups figured out today. We will deal with that tomorrow. Because every time we try to do groups, people end up not showing up for the day of the lab anyway, and we have to redo groups. So we'll just deal with that tomorrow. Yeah. So yeah, that's pretty much it for the background. So yeah, let's talk about the actual lab. So this lab has two purposes. The first one is for you, the actual thing you are going to be doing is you are going to be identifying three unknowns. Those unknowns are lithium, sodium, and potassium. These are pure metals. Unlike in the last lab flame test where they were dissolved in water, or their salt was dissolved in water, so we were going to look at the different colors that have been burned. In this lab, we're going to be collecting observations a little bit more to look at kind of what they do and learn about what is a useful observation versus a not so useful observation is the secondary thing. And you'll be doing a little bit of that as well. So yeah, safety concerns. We're working with three pure alkali metals. Alkali metals are mean. So yeah, let's just run down this list. Lithium metal. Lithium metal is corrosive to body tissues. It can be stored in mineral oil to minimize the odds it comes into contact with water. Lithium is probably the safest of these chemicals because it doesn't tend to burn on contact. But if you actually touch the bare metal, it can cause a pretty significant burn. This says it can be stored under mineral oil, but you can't actually store it under mineral oil because lithium is less dense than mineral oil. So it actually floats on top of the mineral oil. But it does still help to keep it in mineral oil. It kind of slows down the corrosion so that that's less of a concern. So there is that. Lithium, as I am sure you remember from the flame test lab that we did about a month ago, lithium will burn red if it catches fire. You are probably not going to see lithium burn today because lithium, it just doesn't generate enough heat. Yeah, you're not going to see the lithium burn. We will probably see both of the other two burn, but not the lithium. Okay, the sodium metal. Sodium metal is corrosive to body tissues. It will severely burn the skin and the eyes. It must be stored under mineral oil as it reacts violently with water, releasing hydrogen gas which can ignite and may explode. And if it does burn, it will burn orange. So, sodium heats up so fast when it comes in contact with water that it will instantly melt. So lithium, when lithium hits water, it's kind of got a dark gray or black coating on the outside. When it hits the water, that dark coating will kind of seem to boil away, but the shape of the lithium chunk will stay the same. It shrinks, obviously, because it's dissolving in the water. But the lithium shape tends to maintain its shape. If it's flat, it'll stay flat. If it's kind of a cube, it'll stay a cube. Whatever shape it is, it's going to stay that shape. The sodium, however, will melt almost immediately on contact with the water. It'll turn into a sphere and kind of bounce around the inside. It'll shoot all over the place. And because of the amount of heat that's generated when when the sodium melts, it can potentially ignite. So it's not actually dissolving. What's happening is the metal is reacting with the water, and it's producing hydrogen gas. It's a single replacement reaction. The lithium metal is replacing the hydrogen in H2O, and you get Li2O, or Na2O, or K2O. Some of it turns into hydroxides, but we're not going to mess with that. And that hydrogen gas is given off as a byproduct. Now, here's a major safety concern that's not listed in the safety concerns. Try to avoid inhaling the smoke that's coming off of the unknowns as they're sitting there sizzling in the water. That hydrogen gas, it won't do any damage to you, but it will set you to coughing. Pardon. So yeah, if you inhale that hydrogen gas, it can get you coughing. If you are asthmatic and you inhale that hydrogen gas, it can set off some problems for you, so be careful. I will tell you, probably all of you are going to inhale some of it, so if you have an inhaler, it might not be a bad idea to bring it with you into the lab. Nothing, like I said, it's not anything dangerous. It's not going to harm you. It can just kind of set off a coughing fit, and that can potentially cause some other problems. This is primarily a concern with the lithium and the sodium, because there won't be any hydrogen gas left with the potassium. But yeah, that hydrogen gas is given off. Now, with the lithium, it doesn't get hot enough to light the gas. But sodium gets hot enough to actually ignite that hydrogen gas. And so you'll have a little ball of fire shooting all over the top of the beaker. It may or may not light up. Sometimes they just fire sparks out all over the place. Sometimes it's a ball of flame. Sometimes it explodes in like a shotgun blast that comes launching up out the top of your beaker that you're going to be using. So yeah, we'll talk a little bit about that later. The potassium metal is severely corrosive to body tissue and will severely burn skin and eyes. It must be stored in mineral oils that will react violently with water, producing a flame, and this one will blow up. The sodium might blow up, and FYI, the sodium tends to blow up a little more spectacularly than the potassium. But the potassium 100% will blow up. That is why the pieces of potassium that you are going to have are going to be fairly small, because we don't want any giant explosions in a glass container in a sealed room. So yeah, the potassium pieces are going to be fairly small. The sodium pieces will be a little more bigger, so they're a little more likely to go off. So you have to pay attention to the flame color. The potassium will burn, as again you should know, a lilac color, which is a really, really light purple. Old potassium can be coated with peroxides. Those are yellow spots, which will explode when handled or cut. I disposed of all of the old potassium yesterday. If you heard any explosions outside, that was my Chem 2 class and I getting rid of the old potassium and lithium and sodium that had peroxides forming on them. So those are gone. You won't have to worry about peroxides in this lab. Safety precautions. Obviously, everyone is going to be wearing goggles because, duh. Aprons are available if you want them. I don't think any of you have ever used an apron in any of these labs, but they're there. The chemicals we're using are lithium, sodium, potassium, and distilled water, and the apparatus that we're using are going to be a spatula, a beaker, a tweezers, and paper towel. And I just realized that I don't have that stuff sitting here with me, so I'm going to pause this, go get that, and then we'll continue. Alright, I didn't steal it because I'm going to be bringing it back, but I did bring a little bit of each, example of each of these home, so I could kind of show you what we're talking about. So you are not going to be using the beaker until later in the procedure. You are, when you come in, going to find... Should I save this? I should save this part. So I'll just go over what it is. You'll have a beaker. Should be a 1 liter beaker. We might run out of these. We might have a couple like 600s out. You'll have a paper towel, a spatula, and I trust everybody remembers that the pointy end is the end that comes in contact with the chemicals, not the round end. This is the end you touch. This is the end you don't. And this end should always be sitting on top of a paper towel so that someone can tell that this is the end that's actually been used. So don't forget that. The other thing we will have is tweezers, which you'll be using to kind of keep a grip on the unknown because they're going to be very small pieces. These will help. And I'm going to stop here. The next video that you're going to watch is not the other half of my pre-lab video. The next video you're going to watch goes through and gives you a visual of what some of these unknowns look like. So you have seen them ahead of time. It's going to show you lithium, it's going to show you sodium, it's going to show you potassium. The guy in the video is going to cut the pieces off so you can kind of see the corrosion and get an idea of which ones corrode fast, which ones corrode slow, what color are they, stuff like that. He's also going to drop them in water so you can kind of see what happens, but there is no substitution for just seeing it yourself. No video does justice to the colors or what's actually happening in this, so we're going to do it on our own. The video does include rubidium and cesium. High schools cannot get a hold of rubidium and cesium, so I do not have any rubidium and cesium for you. You'll see why when you watch the video. But yeah, I would suggest you watch the video twice. The first time, just, watch it. The second time, you should be taking some notes, either physical or mental, about what properties different unknowns have, particularly the lithium, the sodium, and potassium, because those are some of the things that can help tip you off tomorrow when you have to identify these. Remember, that's the goal. You have to be able to tell me at the end of the lab which one's lithium, which one's sodium, and which one's potassium. They're 15 points each. No, they're not. They're 5 points each. 15 points total for identifying those, and it's very unlikely that you will only have one wrong. If you have one of them wrong, you swapped it with something else, so that means you have 2 wrong. So pay attention to the video, watch it twice, and I will see you in the third video, which will be the second half of this video, where we talk about the procedure and what the actual experiment is going to look like. So I will see you in about 2 copies of video 2.